Mark your own, here we go. Good old Anne. In a flat corner, so this is not a banked corner, this is a flat corner. Well, we said if we draw a quick free body diagram sketch with the car going around the corner, you know what? I'm going to disappoint all of you with my artwork, and I'm just going to represent the car as a dot. I know, Ben, contain your disappointment. What are the forces acting on it? We have gravity down, normal force up, and then because it's going in a circle, we know there has to be a force pointing towards the center. We thought about it for a while, and we said, you know what? Friction is what's pushing us in a circle. And so we ended up with this equation here. Friction is equal to MAC. But then I said, wait a minute, they want me to find the speed, so I'm going to use the V squared over R. Friction is mu times the normal force. I don't know the normal force. Oh, but look. Mu mg equals mv squared over r. I noticed conveniently the m's cancel, and I guess now I have mu, I have g, I have v, I have r. You know what? As far as I'm concerned, I can give you any three of those, find the fourth. So I could even, if I really wanted to, I could put you on a foreign planet and ask you to find what g is on the foreign planet, just for giggles, right? But we can handle it, no problem. Here they want the v by itself, and so I'm going to get the v equals the square root of GER, our old friend. V, oh, no, not the square root of GER, the square root of mu GER. And so I'm going to get 0.655 times Earth's gravity times 30. No idea what the answer is. 0.655 times 9.8 times 30. Square root of that. You get 13.8, is that correct? No? Yes? Meters per second. If you got that correct, 3 out of 3. Otherwise, I would probably go something like this. Half mark if I saw that. 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 Half mark for that. Half mark for the answer. That's probably how I did the up the park marks. A spider sits on a platform rotating at 88 RPM, revolutions per minute, sitting on a record player. This is a job for a free body diagram. This time we have a spider. There's my spider. What are the forces acting on it? Get the obvious one. Gravity. Normal force. Something's got to be pushing it to the center. You know what? It's friction. In fact, this is going to be really similar to the equation that I just did, in that friction is what's pushing me in a circle, except I have to do one extra step, it seems to me. Oh, wait a minute. It wants me to find the speed of the spider. I'm already doing my free body diagram to find the friction coefficient. It wants me to find the speed. Well, the speed is going to be 2 pi r over the period. I don't know the period. I know the frequency, but I don't know the frequency in hertz. I know it in revolutions per minute. So the frequency is 88 RPM. I need to convert that to hertz. It's going to be something to do with a 60, because there's 60 seconds in 1 minute. Believe it or not, this is how I figure it out, because I can't remember whether I divide or whether I multiply. I pick a nice number, 60 hertz, which means 60 RPM, which means 60 times per minute. If it goes around 60 times in 1 minute, if it goes around 60 times in 60 seconds, how long does it take to go around? What's its frequency? 1. I think it's divide by 60. So I'm going to go divide. What did I write? RMP. RPM, is that what you're laughing at? Don't know why that came from. The frequency is 1.46 repeating hertz. So the period is 1 over the frequency. How many of you know that you have a reciprocal button on your calculator? Have you spotted it? It's that little x to the -1 button that all of your scientific calculators do have. That's really going to come in handy when we do circuitry, because there are certain sections where we go reciprocal plus reciprocal plus reciprocal plus reciprocal equals, and we want the reciprocal of the answer. And rather than waste our time typing 1 divided by, 1 divided by, 1 divided by, we're just going to go whammo. And so I get 0.6. Oh, we got someone showing up late. 1 over the frequency. Oh, there's the period point. I'm going to write 0.68, but I'm going to store this on my calculator. In fact, I think it's 6818 repeating. And now I can go V equals 2 pi 0.19, because it's 19 centimeters, all over 0.6818, but I'm going to use my answer button. 2 pi. By the way, please use your pi button. I've seen some people typing 3.14. You're less accurate and more typing. Find your pi button, please. Times 0.19 divided by answer button. Do you get 1.75 that meters per second? So if you got that, 2 out of 2. Otherwise, I would give you a half mark if I saw that, a half mark for that, a half mark for finding the period, and then a half mark for the answer. B wants me to find the friction coefficient that's necessary to keep it in place. So now we're going to say, okay, friction is what's pushing me in a circle. I'm going to use mv squared over r simply because I notice on my calculator I have v sitting right here. You could also use the 4 pi squared r over t squared, because they did, thank you, because they did give you the period. Mu mg equals mv squared over r. Mass cancels. This time they want me to get the mu by itself. So I'm going to get mu equals v squared over g. It's going to be 1.75 squared, answer button squared, all over 9.8 times 0.19. This number squared all over 9.8 times 0.19. And I get a coefficient of friction of 1.65, which I said, you know what, spiders have sticky feet, so it can be bigger than 1. If you used the period, you would get something very, very similar as well. In terms of part marks, 3 out of 3 if you got that. Otherwise, I would probably go something like this. 1 mark for that. I would give you 1 mark for that, or 1 mark for mu mg equals m4 pi squared r over t squared. Then I would give you half mark for the numbers, sorry, half mark for getting the mu by itself, and a half mark for the answer. Then I would turn the page. Ooh, the gravitron. Okay. I think I'm going to do a sketch here. They want the minimum safe radius. I noticed they gave me the period, so I'm going to use the 4 pi squared r over t squared. This is definitely a job for a free body diagram. I'm just going to draw kind of, there's the wall, and we have the person leaning against the wall. I'm just going to represent them with a dot. There they are. What are the forces acting on this person? Get the obvious one. Well, definitely gravity down. Are they sliding down the wall? Are they sliding up the wall? So I know the forces must be balanced vertically. When we did this, we weren't quite sure what that upwards force was. We just knew it had to be there. But we also knew that this person was turning in a circle. Something was pushing it in a circle. We thought about it. We said it's the wall. But what name do we give to the force that's a surface pushing back? Okay, so we said that. And as soon as I called that the normal force, then I went, oh, I'll bet you that's friction, especially because they gave me a mu. And so I would start out by saying, okay, normal force is what's pushing me in a circle. I don't know the normal force. And I can't just say, oh, mg. The normal force is not mg. They're not even in the same direction. But there's another equation kind of hiding here. The second equation is that friction equals mg. The second equation is that mu times the normal force equals mg. I don't know. Oh, you know what? I do know the normal force. Apparently, the normal force is equal to mg divided by the coefficient of friction in this particular question. So, I can walk that here. I'm going to get mg over mu equals m 4 pi squared r over t squared. Chad, can little kids and grown-ups go on this ride? Why? Well, that's convenient. Again, though, let me always emphasize, if I actually said find the normal force itself, then the m wouldn't cancel, and it's why as you get older, sorry to spoil it, you may find rides that you liked as a kid your body just can't handle anymore. I'm still doing okay, but I know a friend of mine who's older is enjoying trips to amusement parks less and less and less now. Okay. What was I trying to find? What letter is that? I went to go see a pirate movie the other day, but I couldn't get in because it was rated R. No? Nothing? Okay. Really? That's a dad joke? Okay. Okay. Note to self. Improve my material.
Every month I've heard that.
Okay. You know what? I sense I've just traumatized my friend. Like he's, you know, someday you're quote unquote a psychiatrist you're going to be talking about today, right? To get the r by itself, I think times by t squared, divide by 4 pi squared. Because when you have one fraction equals one fraction, stuff just moves diagonally across the equal sign. So I think r is going to be gt squared all over mu 4 pi squared. I think that's right. Yep. G 9.8. Period 3.2. Don't forget the squared. All over mu 0.45. This, by the way, is probably, if you were designing this ride, you probably know how fast the motor could spin the ride. So you'd know the period. You'd know what fabric you were using. You'd know its coefficient of friction. How big a radius do we need to build for this ride to work? 4 pi squared. I have no idea what the answer here is going to be. Is this a fraction? Yeah. Definitely got to put the bottom in brackets. I can get away without putting the top in brackets because it's all multiply. I think. If I made a dumb mistake, I think I'm good. You get 5.65? Yep. That's about right. 5.6 meters, that's roughly from me to about where Chad is. That's the radius. I've been in the gravitron. The center is about that far away, and the people, I might be a little high. I don't know. That's pretty close. If I'd gotten an answer of like 96 meters, I would have been a little worried because you don't build rides that big is all. If you got that right, 7 out of 7. Otherwise, I would probably give you 1 mark for that. I would give you 1 mark if I saw that you got an equation for the normal force. I would give you 1 mark for that. That's 3, 4, 5, 6. You know what? I might even give you 1 mark for the free body diagram or something like that. That's 7. But if you got the right answer, 7 out of 7. Can you give yourself a lovely score, please, out of 15? First of all, I also just gave you quiz 3. Can you take a quick look at quiz 3? On the test, you can absolutely expect on the written section, first of all, on the multiple choice section, expect conceptual questions about which way your velocity is, which way your force is, which way your acceleration is if you're moving in a circle. That's absolutely, in fact, it's probably going to be one of those 2-column, pick the right answer questions, okay? You can, on the written, absolutely expect some kind of vertical loop either a roller coaster or a Ferris wheel or a skateboard pipe, which is really just a roller coaster by another name, but some kind of vertical loop. I'm probably going to put the gravitron or artificial space station gravity, because in both of them, the normal force is what's pushing you in a circle. The gravitron's a bit trickier because you also have gravity and friction. Out in outer space, it was a simpler diagram when we did artificial gravity because there was no gravity. But then I'm either going to put a banked corner, like number 1, or I'm going to put a conical pendulum, like number 2 on this quiz. I will not, however, ask you to find an angle theta. We did one banked corner question where we found the angle, and that's an interesting engineering challenge. You would say, oh, I know what radius I have to work with because of the landscape, and I know how fast I'd like the speed limit to be. What do I need to bank the corner at for safety? And that's, okay, that's a nice engineering question, but I'm not going to do that. We did the roller coaster loop last day where we found how high the hill had to be. I love that question because the answers were so clean. I think it was 2.5 times the radius, and we found 6 G's at the bottom. And I have a fondness then when a really complicated long question, when stuff starts canceling all over the place and you end up with something so tiny, it does make my little math nerd heart go pitter-pat. I still, to this day, Chad, every time I cancel out the M's, earlier when I said, can little kids in grown-ups go on? I have to admit, my little math nerd heart goes pitter-pat every time. I like it when I can simplify stuff. I'm not going to give you one of those on your test. It's just too long. It's multiple steps. By the way, not really that hard once you walked your way through it, but it was just too long. So, but you can expect one of these, and then, here's a fair example. Finding the normal force on the roller coaster at location B. This is sort of what we did. This is probably tougher than I'm going to ask on your test. This is what we did under cool applications, where we calculated 6 G's at the bottom. I don't think we calculated the normal force at the top, but you can. Is there a change in the height? Is there a change in speed? Is there a yucky curvy path? You're going to have to use both conservation of energy and circular motion. It's a nice question. It's just way too long, but it's great practice for your test. So I don't mind giving the quiz a little tougher than the test. Okay? So, having said that, hopefully I've stalled long enough that all of you have got out the ultimate review. You found it okay? No? Okay, you might want to just jot these numbers down. Or you can choose to circle them or whatever. I'll tell you which questions that you can do from this review. Again, you don't need to hand this one in on test day, but these are good questions. Number 1, absolutely. 2 is good. 3 is good. 3 is the question that I just said to you I wasn't going to ask on the test because it's just so long. And you also might remember the punchline. I think the answer is going to be 2.5 times the radius, which means it's going to be 2.5 times 6. But if you want to just, for practice, do conservation of energy in the proof, you can. 4 talking about gravitational field strength? Not 4. Eventually. Is 5 talking about satellites? Can't do that yet. Is 6 talking about orbits? Can't do that yet. Spacecraft, number 7? Nope. But number 8 is good. Number 9 is good. Number 9 is asking you a graph, and it's saying which shows the relationship. Remember I taught you graphing tricks? It says, what's the relationship between A and V? What's the equation that has A and V in it for moving in a circle? A equals? Adam. Adam. Say it louder. V what? V what? I'll bet you it's a parabola. What's the correct answer? More specific, A, B, or C, or D? Yeah. Those are the graphing tricks that you can start to kind of use. Oh, it's related with a squared. I don't know exactly how steep the graph's going to be, but it's going to look like a parabola. Okay, so there, I just did that one. Number 10 is nasty but cool. Number 10 is probably either harder than I'll ask, or that would be an example of, oh, he's going to ask one nasty multiple choice question. That might be an example. Look at my online solution key. However, here's what we are imagining. We're imagining that Tarzan is holding the rope exactly perpendicular to the cliff, and then he jumps. Okay? What's the tension force in the vine as Tarzan passes the lowest point of his circular path? How many of you have ever been on a rope swing or had a rope swing before? Yeah? How many of you have ever seen somebody face plant on the rope swing because they lost their grip? Where do they lose their grip? You'll find if you calculate, if you're starting dead horizontal and swinging all the way, which most rope swings don't do, you'll find the number of G's at the bottom required to, first of all, what path are you tracing out? What force is pulling you in a circle? Well, it's the rope, but what's holding you on the rope is your hands, so your hands also have to be able to resist that tension force. You'll find it's a fair number of G's at the bottom, which is why people often face plant on rope swing. Just nerd trivia. Skip 11 for now, skip 12 for now, skip 13 for now. 14 is good. 15 is good. 16 is good. Skip 17. 18 is good. Skip 19. 20 is good. 21 is good. 22 is good. Skip 23, skip 24, skip 25, skip 26. 27 is awesome. Although it just wants the free body diagram, but still. I don't remember. I think I said skip 26. Is there a planet and orbits and space? You can't do that yet. 28 is good. 27 is good. Skip 29, skip 30, skip 31. "32 is good. Here's a using principles of physics right to explain. So initially, I guess tension is 14 newtons, because that's what the spring scale is reading, and it would measure tension in that alignment. What would happen to tension as it swings? Probably a job for I bet you a good free body diagram. You'll find, I'll bet you if you get tension by itself, you're either adding something to it or subtracting something from it, and you might say, oh, it's either bigger or smaller, or it might stay the same, but I doubt it. 33 is good. 34 is good. 35 is good. Skip 36, skip 37, skip 38. 39 is good. 40 is good. 41 is good. Skip 42. Satellite, skip 43. 44 is good. Although it says it's a satellite, hey, it's moving in a circle. In fact, which is the correct answer for the acceleration? 1, 2, 3, or 4? 2. Which is the correct answer for its orbital speed direction?
1.
No. 4, right? At right angles to the radius. Which is the best answer for the force direction? What was the best answer for acceleration? So which way is the best answer for the force? Because F equals what? Yeah, force gets its direction from the acceleration. By the way, what force is that for a satellite? If you want the punchline, once we start looking at orbits, it's going to be gravity is what's pulling us in a circle, but we're going to do Newton's universal law of gravity. mg only works on the surface of the Earth. What if you're out in space somewhere? We're going to learn how to calculate little g anywhere, and then we'll use that to modify a universal gravitation equation. That's what, when they talk about Newton, quote, discovering the law of gravity, that's the equation they're talking about. 5 is good. Skip 6. No, we can do 6. What's the acceleration as the Earth orbits the sun? You have all the numbers required to do that one on your formula sheet. I think you're going to use the 4 pi squared r over t squared, because I'm pretty sure your formula sheet gave you the period of rotation as opposed to the speed. Oh, they can figure that out. 47 is good. Remember the graphing tricks that I showed you? Nick, what's this want me to find? What is the? I would look at the equation for FC. I would look at the equation, oh, wait a minute, slope is what over what? Did you say over? You know what, for slope we divide. I would try dividing FC by V squared and asking what would be left on the other side of the equal sign. Probably got like M's and R's and stuff, I don't know. Skip 48. Skip 49. Skip 50. Now, the scholarship questions are always optional, but I know that some of you are going for 100% in my course, and you like the challenge, and you can try them. I have my steps shown. 50, no. 51's cool, but no. Cycling on an asteroid is just cool. 52, no, not yet. 53 is doable. What are they asking you to find in number 53? Yeah, so what are they asking you to find? Where does that show up? What letter have we used for that? You're going to find little g. So this is analyzing the roller coaster loop. Is there a change in height? Is there a change in speed? Is there a yucky curvy path? Yes, yes, yes. You're going to be doing conservation of energy. For this one, I guess the g's won't cancel. And eventually, you're going to get the little g by itself. It's doable. It's a lot of work, but it's doable. 54 is a banked corner. It's doable. What you'll end up finding, I think, is the radius r. And then if you pick up this triangle, you have r, you have d. You know that this angle right here is 42 degrees. How big is that angle right there? More specific as a number exactly. 48. 48. And then you can find D. Otherwise, it's actually not that. For 12 marks, I thought this was actually a fairly easy scholarship question. It was the banked corner, find R, and then do a little trig. 55, no. And then there's your answers. And you have a take-home quiz.